All right, for the following signal, this is a multiple choice question, and we want to find the energy and the average power for the signal. You can choose none of these. So we want to find this though without evaluating the expression for the energy and the average power, which is the limit from which t approaches infinity, and we take the and in this case is continuous time, so we integrate that signal from negative infinity to positive infinity, and that would be the absolute value of the signal x of t squared. We don't want to go through all that. We just want to choose one of the following: A, B, C, or D. Well, you can approach it graphically, or you can say that in this case there will be a discontinuity in the integration of the signal x of t, because we have a sum of two exponential signals. So we can approach it graphically by saying that the signal x of t, and we have x of t, the first expression, which is e to the positive t times the unit step function, the inverted unit step function. And we're just going to say that this is e to the t u of minus t. And for this one, and both should intersect at the same place. And this is e to the negative. This was e to the negative t. So excuse me, e to negative t, and this is e to the t, because this is increasing unit step, and that is u of positive t. So thus we change this around, and we change this around. So in this case, we know that the unit, I'm just going to do this quickly. The first one in this case is u of t, and the second one in this case is u minus t. It is the reflected version. I think I said inverted, but you could call it inverted. U of minus t is the reflected version of u of t, and that is 0, as you can see, for 0 for t greater than 0, and it's 1 for t less than or equal. So that's 1 for t less than or equal to 0. In this case, this is 1 for t greater than or equal to 0, and 0 for t less than 0. So we see that the exponential functions are bounded by the unit step. So we see that in this case, we can take that away, take this away, and we end up with the expression x of t. This is because the unit step function u of t is 0 for t less than 0. So this would be 0 for t less than 0. And in this case, the reflected unit step function would be 0 for t greater than 0. So now we see if we integrate this expression or this function x of t, there is a discontinuity in that portion of the graph. So thus we cannot integrate over an infinite interval. And if we cannot integrate over an infinite interval, we know that the energy for that signal will be less than infinity, because if we integrate over a finite interval, we get, so in this case, this would be from negative infinity to 0 and then infinity. So in this case, the integration for this would be negative infinity to 0 plus 0 to positive infinity. And that's basically adding two intervals together, which would equal a finite interval. And if we integrate over a finite interval, the energy for that signal will be finite, which is less than infinity. And if the signal And if the energy in this case is less than infinity, thus the average power is going to be equal to 0, which is less than infinity. So if we look at the choices that we have, the first one here, A, is with energy less than infinity, and the average power is less than infinity. Well, that one is actually good. And we look at B, the energy is equal to infinity, thus we can move on. We don't want to use that one because that's wrong. And we look at C, the energy is less than infinity, which is the same as A. Only thing different is that the average power is equal to infinity. In this case, we know that the average power cannot be equal to infinity. And D is totally incorrect because the energy is equal to infinity and the average power is equal to infinity. So in this case, A is the correct choice. And that will be the last video on energy and power in signals and system. All right, see you in the next set of videos. Bye.